Hi, everyone. Thank you for coming to lecture 5, Smart Contracts. So as a brief agenda, today we'll be talking about 4 topics. First is the programmable blockchain. Then we have the EVM, which is the Ethereum virtual machine. Third up, we have the ERC20 token smart contract. Those are just an example of a smart contract. And finally, we're going to talk about some dApps, which are decentralized applications. To start off, we'll talk about the programmable blockchain, but as some review, we'll talk about Bitcoin. So as a review, the blockchain is essentially a digital decentralized ledger that records transactions and data in a series of connected blocks. So essentially, Bitcoin is the first decentralized currency, and it's also like the fundamental first modern blockchain that we have. And all blockchains essentially, or most blockchains operate on a peer-to-peer network, which allows users to send and receive transactions directly without the need for an intermediary. So to review some stuff from last week, we're going to talk about transactions, which are essentially a request to make a change to the current state of the blockchain. So essentially in Bitcoin, whenever someone else sends a Bitcoin to someone else, the global state of the blockchain is changed. And you can see that here when someone sends a transaction, A sends 50 coins to B, you can see that the global state of the blockchain has changed. All right, so that brings us to Ethereum, which is, I guess you could call like the second generation of blockchain. Bitcoin, of course, was a fundamental blockchain that didn't have smart contracts. Pretty much it was just used for sending transactions. But now we have Ethereum, which we call the programmable blockchain. The door's locked. And it's essentially called the programmable blockchain because of something called smart contracts. But briefly, we're going to talk about Ether, which is Ethereum's native coin. Ether is essentially used to pay for transaction fees and computational resources. And Ether in this case is used to run smart contracts, which is one example of when computational resources are needed. So this Ether that is consumed during script execution is called gas, which essentially limits the amount of computations you can make, and the price of gas fluctuates depending on network traffic. And the reason why you need this gas in the first place is because you want to prevent denial of service attacks and infinite loops and essentially just spamming of the blockchain. So that's something you want to prevent. So now this is just an example of the difference between blockchain or the two blockchains, Bitcoin and Ethereum. In this case, this one on the right is what smart contracts allow you to do. You can send not only money, but also data. Bitcoin was pretty much on the left where you can only just send money. All right, so briefly, what exactly are smart contracts? I know I've said that word quite a few times already. To put in simple terms in a few sentences, smart contracts are essentially just lines of code. So these lines of code are stored on the blockchain and they have essentially some conditions written into that code where they say, okay, once these certain conditions are met, this outcome will be executed. So it's essentially just kind of like an if-then sort of situation where if these certain conditions are met, then these outcomes will be executed. So briefly, we're going to give you a quick analogy of why we need smart contracts and why they can be helpful in certain situations. So one main issue that we have today in traditional contracts is the fact that we need to trust other individuals in order to allow the contract's outcomes to actually happen. So we'll take a simple example of a bike race. Let's say Alice and Bob bet that they're each going to win the race. So Alice bets that she's going to win the race. Bob bets that he's going to win the race. Whoever wins the race wins the $10. So let's say Bob agrees to the terms because he thinks, okay, yeah, for sure, I'm going to win. But then the real result is that Alice wins. And so Bob is kind of petty, he's like, no, like I was supposed to win. I didn't win. I won't pay you the $10. So essentially in this case, we need to trust essentially both parties to carry out their terms of the agreement. And this is one reason why, smart contracts could come in handy because it's an automatic execution of something. So essentially, like I said before, smart contracts are or automatically execute certain conditions. So when certain conditions are met, then the contract conditions are realized. And that is why they remove the need for trust. So in Alice and Bob's case, let's say there's some sort of program written that can like scan, like like let's say they're each wearing a number, like Alice is 1, Bob is 2. Let's say some sort of camera sees, okay, Alice won, she's number 1. So then payment of the $10 goes to whoever is number 1. In this case, it's Alice. So this is one scenario where smart contracts could come in handy. All right, and we're gonna give another analogy just to sort of help you solidify the information in your mind. Let's say a parent puts funds in escrow for their child, but they only allow the child to withdraw the funds after a certain date. So let's say that certain date is January 1st, 2024. Right now, because it's not yet 2024, if the child tries to withdraw the funds from the escrow, they won't be able to because the smart contract prevents them from doing so. But as soon as January 1st, 2024 rolls around, the smart contract is automatically going to allow that child to withdraw the funds from escrow whenever they'd like. Cool. So what are some characteristics of smart contracts? We have 5 key elements listed on the screen. First one is that they can carry any arbitrary state, meaning they can perform pretty much any computation as long as it's written into those lines of code by the developers, and it's written into the smart contracts. Second is something we'll talk about a little bit later with JC, is that smart contracts can call other smart contracts on the Ethereum blockchain. So essentially, like in tandem, you can use multiple smart contracts at a time to help, like something more complicated happen. Third, smart contracts are run by each node as a part of the block verification process. Fourth, they each have their own address, which are used to identify the smart contract and interact with them. And lastly, they're immutable, meaning that once they're created and put onto the chain, they cannot be changed. So when a user wants to execute a function within a specific smart contract, they essentially send a transaction to the contract's address, which is why it's important that each smart contract have their own address. And so essentially, once they send a transaction to the contract's address, this triggers a function to execute on the Ethereum virtual machine, which is the EVM, and JC is going to talk a bit more about that.
All right, so what is the Ethereum virtual machine? The Ethereum virtual machine is pretty much a decentralized virtual world computer that executes smart contracts on the Ethereum blockchain. So what does this mean? Pretty much, so think of like a typical computer you have at home. This Ethereum virtual machine is similar to your computer, but it runs on, it's like all of the nodes that are connected on Ethereum, and it uses their power to pretty much create this like supercomputer. And it's an isolated environment for executing smart contracts. And each smart contract also runs independently, which means you cannot access the memory, storage, or other resources of other contracts directly. And it also ensures the security and stability across the network. But there are times where you can call on methods of other contracts. But it doesn't really, so there are 2 things you have to know. There's Solidity, which is what you use to code these smart contracts. And on the left right here, you can see a smart contract that has been coded in Solidity. And then on the right-hand side, we have bytecode. And this is pretty analogous to like C++ and bytecode. I don't know if you guys have that much of an understanding with computer science terms, but there's JavaScript and let's say C++. Those are like higher level codes or programs. And pretty much what this means is that it's human readable, but there's also the bytecode, which is lower level, and that's what the computer actually executes. So this is pretty much the exact same thing for the Ethereum virtual machine. You write in Solidity, but the code that actually gets executed is the bytecode. And so there's also the world state, and the EVM maintains a global state, which is called the world state. And this keeps track of the current state of all the accounts on the Ethereum network. And each account includes an address, a nonce, ether balance, and a contract if it is a smart contract, and storage. And this updates after each extra transaction is executed. So some takeaways are that smart contracts are decentralized, immutable computer programs. They execute on the EVM, and they're accessible to anyone with internet connections and the appropriate permissions to interact with them.
Right, so briefly, we're going to talk about the ERC20 token smart contract. This might seem like just a lot of letters, but this is just one example that we're going to use. There's many other types of smart contracts, but in this lecture, we're just going to focus specifically on the ERC20 token smart contract, just so we can illustrate to you like how powerful they are, because these pretty much just open up the blockchain industry a whole lot more. So I guess the first thing to talk about is what is the ERC20 and why do we need it? So what it is that it's a smart contract that specifically defines a set of rules needed to create and manage fungible tokens that are built on top of the Ethereum network. So what that means is essentially if a company, a group, an individual, like whoever wants to create a token on top of the Ethereum network, if they want to do that, they have to follow the rules that are listed on the smart contract. And so you can think of it like a blueprint, essentially. It's just like guidelines for people to follow if they want to create their own token on top of the Ethereum network. And so why do we need this sort of blueprint and the ERC20 token smart contract? Well, that is because we do need a common standard for these tokens that are created on top of the network. Because it's similar to like why we have rules and regulations nowadays. You can't just create whatever you want. So this does like give you freedom to create these specific tokens, but at the same time, it also sets some boundaries just for like security and safety sake, which we'll get into a little bit later. Right, so what are some advantages of the ERC20 tokens? So these ERC20 smart contracts essentially make it easier for companies to create their own blockchain products without having to develop their own cryptocurrency from scratch. And so these ERC20 tokens have the following three pretty important features. First off, they're fungible, which means that every token is the same and interchangeable, and which essentially means that on the back end in the coding world, every company's token has identical code / backbone. But one thing to note is that even though the code is the same and pretty much the program itself is the same, like the token's code itself is the same. Of course, the transaction history is going to differ depending on like company A's token versus company B's token, because they do act like separate tokens. Second is that it's transferable, meaning it can just be sent between addresses and transactions can be made. Third is that there's a suggested fixed supply. So it's not like a hard limit, like there has to be a fixed supply and you can't create any more tokens. It's more so that if developers issue more tokens post creation, that information will be broadcasted to like the entire network. So it kind of like prevents inflation indirectly, where it's like, hey, if you issue a bunch more tokens, everyone will know. So try not to cause inflation. Right, so the ERC20 token is also known as the utility token. It's a type of utility token, which are usually pretty much just tokens used to pay for goods and services. So again, because we talked about advantages, we should also talk about disadvantages. The main disadvantage of ERC20 tokens is that it leads to congestion on the Ethereum network. And congestion means that the time taken to mine blocks increases with congestion. So the reason there's a lot of congestion is because, again, all these tokens are built on the Ethereum network, so they do use the Ethereum network. And so this congestion causes slower transactions, but more importantly, it causes high and expensive transaction fees. And also, because we have like the rules and guidelines created, and because it does make creating blockchain products easier, again, this ease of creation does mean that there's a potential for scam tokens.
All right, so I'm going to show you guys an example of a smart contract, and I'm using a website called Remix, which we'll share later on. All right, so right here, I created a contract. It's called Simple Bank, and pretty much here are all the functions. So this is the state of the Simple Bank. It's just a variable called balances. Oh, Jack. And then these are all the functions that I mentioned before. There's a function called deposit. There's also a check balance function, and then there's also a withdraw function. So if you think of Bitcoin and blockchain, pretty much before, as we said, they're just transactions and all the different accounts that are stored on the blockchain. But here we have something different. It's this right here, this contract, this piece of code is stored on the blockchain. And then anyone who has the ability to access, or pretty much anyone in the world, they can look at this contract and interact with it somehow. and that means anyone could deposit some amount of coins into this contract. You could also check the balance of that contract, and you can withdraw something from that contract. So we're going to go ahead and first you have to actually compile this code. So it's called simplebank.sol, and .sol stands for solidity. So let's go ahead and compile it. So after we compile it, the next thing we have to do is actually deploy and run this transaction. So right now I'm connected to Remix's kind of like fake virtual environment. And what I'm going to do, I just simply press deploy. And now right here, you can see that there's a little check mark, and pretty much this piece of contract or this piece of code was now created into an object, which is now on the blockchain. So this is actually on the blockchain, or like our fake little blockchain right now. And if we want to interact with it, we can go down here to deployed contracts. We press here and we can say, let's say we want to check the balance. So we're calling this function, which is called check balance. We just press on it and you can see there's a function call right here. And if you see right down here, it means there's currently, there's currently a value of 0 in the smart contract. But if we want to put some Ethereum into the contract, then we can go up here, and Wei is just a smaller amount of ETH or Ether. But let's say we put 200 Wei or 2000 Wei, and we now deposit that into the contract. You can see that the balance here increased. And if we check the balance now, it says there's 2000 right here. And then you can also withdraw a certain amount by, let's say we want to withdraw like 20. And it kind of takes this out of the contract and puts it back into our account. So if we check the balance again, it should be 1980, which is right here again. So all of this was done in a virtual environment. But if we actually want to put this on the blockchain, we can simply recompile this again. Then we go to deploy. And right here, I'm going to connect to MetaMask, which is pretty much like my own account I have. And we're going to deploy this to a test net, not the real mainnet, where I guess it's just like a little test net. So we go press deploy. And right here on the top right, you can see, so this is the gas we talked about, and this is how much it's going to actually cost for the transaction to go through. And so it doesn't cost that much, but we pretty much just press confirm. It's pretty easy. And then if we go on Etherscan, and Etherscan is just like a way to actually see or look at all the whole Ethereum blockchain. But we can see right now that the contract is pending, so it's about to be created. But before I actually created, I created the same thing. And you can see this contract, this is its value on the Ethereum blockchain. You can go down here and see it was created. And then again, okay, let's see here. This is the bytecode, as I explained previously. It's pretty, you can't really read it. And yeah, that's just a quick introduction to smart contracts. Do you guys have any questions for this particular part? Yeah.
So when you check the balance,
yeah.
Is that telling you the balance that's currently in the blockchain?
So okay, so it's the balance that's in the contract. So the contract, just think of it as a box, and it's it can have stuff inside that box, and it can also have these functions. There's a withdraw function, which means you take you withdraw a certain amount of Ethereum out of the box. There's a deposit, which means you can put a certain amount of Ethereum into the box. And there's also a check balance, which just means you can check how much there is in the box. So initially, when you create this contract, you're just creating this box, and this box is on the Ethereum blockchain. So then anyone can interact with that if you have access to the Ethereum blockchain. So you could put in 2000 Ethereum, you can take out, but let's say if you're trying to take out 2000 Ethereum and the value of the box is right now 0, that's not going to work. So it's going to give you an error. So we could try that. Let's say we go here. Let me redeploy this real quickly. Where is it? compile, remix. Okay, so we're gonna go here. Right now, you see the balance right here, it's 0 Ethereum. And if I want to withdraw 200, it's gonna give me this like error. And then it's, let's see. And basically the reason it does this is because, where is it? It checks right here if there's enough Ethereum in that like contract. If there isn't enough Ethereum, then you can't take it up 200. Yeah.
So like when you have like a completely different transaction on a different day, it's not necessarily going to connect to that same thing. It's just like one individual contract.
So there's the contract, like this is the code for the contract. And once I deploy that piece of, or like, so there's, let's have the contract. And then once you deploy it, it creates an object, and that object lives on the Ethereum blockchain. And that's going to stay there forever pretty much, unless you have some function that can like destroy it. But if it's going to stay there forever. So if you went back home today, create a contract similar to this and put it on the actual Ethereum mainnet, it's going to stay there pretty much forever. And you could deposit 200 today, and it would stay there just forever, unless someone tries to take it out.
And then you can go directly back to that specific transaction and withdraw whatever.
Yeah. And it pretty much just stays on the, yeah, exactly. And now if we actually go back to the transaction, oh, it's still pending, okay. Okay, yeah, you can see it 3 minutes ago, that contract was made. And then this is, again, the contract, this is the address. This is where that like box, that contract lives on the Ethereum blockchain. Yeah.
Access to the Ethereum blockchain.
I mean, so you can connect, pretty much anyone like can connect to it through like, let's say like, if you have like a wallet, then you can actually connect to it. So it's pretty easy to do. But when I say like has access to it, I just mean has access to an internet connection. And yeah, that's all. It pretty much all it requires is just like a tool like Remix. This is just like a code editor, and it also allows you to like actually interact with it as long as you have an account that's on the Ethereum test network. And right here, you can see that I'm using a test network called the Gorley test network. So yeah.
How do I access the Ethereum blockchain without having to rely on apps that I can make that with people?
That's harder to do, but right now, like this is the easiest way to go about it. Yeah. All right.
Okay, so now we've pretty much spent like this entire first portion of the presentation talking about pretty technical topics like smart contracts, Ethereum virtual machine, and the ERC-20. Why does any of this matter? Well, now JC is going to talk about some applications, which are pretty much just called dApps, decentralized applications, and what we can do from there.
So what are dApps? Well, again, they're decentralized applications, and they're applications that run on a decentralized network such as Ethereum. And often, or pretty much all the time, they use smart contracts that automate the process without a central authority. So this is an example of a decentralized application. It's called a decentralized autonomous organization, also DAO. And it's pretty much the backbone, again, of a DAO is its smart contract, which defines the rules of the organization and holds the group's treasury. So you can think, and then again, no one can spend the money without the group's approval, and no one can change the rules except by a vote. And DAOs also don't need a central authority, which means the decisions are collective, and there's automatic authorization of payments when votes pass. So here's an example. Let's say you want to create a charity, and you can accept donations from anyone in the world and vote on some cause to fund. So you could encode this, as I showed you guys previously, in a smart contract, put that on the Ethereum blockchain, and then you could have people who are like part of that, or like, let's say you have the contract, right? And then in that contract, you list everyone who's a part of that organization, and everyone who's a part of that organization can then vote on certain things. So let's say you want to, I don't know, you accept some donation, and then someone like brings up a proposal and says they want to, I don't know, donate that to some organization. Well, then that one person brings up that proposal, and then everyone who's connected to that smart contract gets to vote. And if the vote passes, then you'll actually donate to that organization. And then, yeah. Another example is collective ownership, and you could purchase physical or digital assets, and members can vote on how to use them. Any questions on this slide? All good? All right. There's also decentralized arts and collectibles. This is pretty famous, NFTs, and pretty much they're used to represent anything that is unique as an Ethereum-based asset. Ownership of an asset is secured by the Ethereum blockchain, and no one can modify the record of ownership or copy/paste a new NFT into existence. And then again, I quickly want to briefly go over this. NFTs stand for non-fungible tokens, and this means they're not interchangeable for other items because they have unique properties. There's also fungible items, and these can be exchanged because their value defines them rather than their unique properties. An example of a fungible item is Ethereum, because one Ethereum / one USD is exchangeable for another one Ethereum / one USD. So this is an example of a DApp. It's called OpenSea, and it's pretty much, so this is called BASIC or Bored Ape, and we use these smart contracts to facilitate the trading of NFTs. So let's say I want to own the guy in the middle, and Isabel owns the guy in the middle. Well, then on the Ethereum blockchain, it shows that she has ownership of that ape, and I want him. So then I have to, let's say, exchange or give her like 70 Ethereum, and then that's how we transfer ownership. And these smart contracts, as I showed previously, are what we use to facilitate that trade. And here's the quiz attendance form. Thank you for coming today. If you guys have any questions, feel free to ask.
And if I were to interact with this thing,
Yeah.
I would just be like trusting that whatever you've implemented works in a way that I want it to work, I suppose.
I mean, that's the thing where a lot of times there are contracts that are malicious. So they'll trick you. They say, oh, if you submit 2 Ethereum, you're going to get 10 times that. And then that happens. Then they take your Ethereum and you don't get anything back. So it's hard because it's hidden in the contract's code. So you can get screwed over a lot of times if you don't properly look at the code.
And then, so you said like, you said that the contracts are run on the EVM,
Yeah.
which I guess somehow is sharing all of the nodes that make it up or something. So like, can I just send a contract that it's just like no conditions, just run rm-rf star and like delete everything on all of the nodes?
Okay,
like,
so
with parentheses.
well, there's a thing, like there's one problem that exists or like that was thought of. Let's say one of these smart contracts goes in an infinite loop. So you never know with these contracts if they're ever going to stop or not, right? And that's like where gas comes in. So that's why also the contracts, like they cost a certain amount of gas, because like if a node or a contract was to get in an infinite loop, then it would keep on going and kind of like screw over all the other nodes, right?
Sure.
So that's why there's a gas limit. And then as far as like being able to interact with other contracts, there are certain like you can make them private or like public. So not all contracts can like call the other methods of other contracts. It like depends on it, but
like maybe I just want to destroy the nodes that the contract is running, and like that executes and it ends. There's no infinite loop. It just does stuff to destroy some nodes for fun.
That's sort of I think what JC mentioned before, like gas comes into play. Like there's nothing stopping malicious. Or are you asking a different question?
I'm not sure. I'm not very sure
Are you
how
asking,
that.
like if the smart contract can destroy like the node that it lives on.
Sure. Why not?
It can't.
I don't think, yeah.
Just and I think that gets into the very technical aspects of it, where it's like just. So I think the thing that you have to, the part you have to distinguish is that smart contracts live on top of the node. I wouldn't say like they're directly like.
It's like a virtual machine. So
Sure, I mean, they don't have to destroy the node, they could destroy the virtual machine, I don't know.
I just don't think it like, I'm sure there probably someone can do that, maybe. But I like with our current capability and like, or like, I don't think it has access to those things. Yeah.
Let's say like even if it does have access, that's where the like issue of DAS comes into play, where there's nothing really stopping malicious actors from doing what they want to do, except for that price limit. Because gas can get very expensive, so like at a certain point, there's a certain element.
Yeah, I think it's just mainly confined to the virtual machine, so that's why you can't really do it that much.
So also, I think one thing to note is that like once a block is created, it can't be changed. So the smart contract can't change the information on the block.